Today we are going to show you few of the applications of number theory as well as abstract algebra in day-to-day security issues. For I think I will take around 2 to 3 classes on this basic cryptographic schemes, which mostly involves number theory and abstract algebra. But before going to the details of basic cryptographic schemes, let us first have a look at why these security issues are required for our day-to-day life. Okay, so the basic motivation of this course is to show few applications of number theory. So I will start from very basic primitives of cryptographic schemes, which were actually used maybe in the era of BC, so before Christ, and then I will talk about very recent few developments of the things, and then talk about few of the very important things where number theories and especially the prime numbers plays the most important role. So in my previous classes, the last 6 classes, I have already developed all the prerequisites that are required for this cryptographic schemes. And then when we talk about number theory and especially big primes, so I will show you what do we mean by big primes. Then in this course, if I'll get some time, I will show you how to get this big primes. So based on this, the cryptographic scheme will be developed, and I will show you how to do this. And maybe in my previous courses, I have taken few classes on C programming as well. So those who are comfortable in C programming, they may go for the implementation of the schemes. They are very easy to implement, but it requires a little bit of practice to do C programming or something. If somebody is interested to implement it in Python, they can also do this. But I may show you how to implement it in C. That would be easier for all of you. So let's start with this idea. So before going into much details, let me first give a kind of brief introduction about why we require security. So let me start with an announcement of a course or something from my website. Suppose this is my website, and in my website, I just given it a kind of announcement that I am giving back to my community due to COVID-19. All Bitcoin sent to my address below will be sent back doubled. That means those who will give me, say, $2,000 to my account, I will give them back $4,000. And this is the ID for my Bitcoin link. So you can send using your Bitcoin link. And this is valid only for 30 minutes. So please enjoy. So if I post this kind of announcement in my website, then certainly either you may think that I am a mad, or I become a mad during this pandemic situation, or you may think that I am joking with all of you. But the question is why I have posted this kind of announcement in my website. Let us have a look at in a bigger way. So this is the Twitter verified Twitter account of Barack Obama, who was the 44th president of United States. And you can see that there are billions of millions of users or followers actually following his tweets. So whatever he writes within fraction of seconds, that gets viral. Uh, but if you look at carefully, the announcement that I have posted in my website, the same announcement was also posted in Barack Obama's verified Twitter account. The only difference is here this Bitcoin link is little bit distorted, so you cannot read this. Otherwise, all the things are exactly the same. So I have just basically copied this, and you can see that this message was lasted in the Twitter account of Barack Obama only for 57 seconds. But being the celebrity, within this fraction of second, his message got viral, and many people actually sent the say $1,000 of money to through this Bitcoin, and they let's see what happened to them. Not only this, the same thing also happened for Bill Gates. You all know Bill Gates. Now you all know Joe Biden. so who is currently the president, maybe the official president of United States now, and Elon Musk. So he is again a very big shot, and there are plenty of people's Twitter account. The same message was reflected. So now you can think that okay, you may be a loser because you might have you haven't seen this kind of message. Otherwise, you could have also sent some amount of money to their account so that you get the double of it. But it happened actually around 3 months back during this lockdown period, and after few hours. So you can see that all the messages actually they lasted only for say 1 minute or fraction of minute. But within that, being they are very popular persons, this message actually got viral, and many people from United States and not only United States, all over the world, they actually sent the money through this Bitcoin link. And after a few hours, it revealed that it was a scam and it was known as the Twitter Bitcoin scam. So this is known as the biggest Bitcoin scam during this lockdown period. So now you can understand that you are now lucky because you haven't seen this kind of message and you haven't sent money to their account. So it was a scam basically. And many people lost their money within say 1 or 2 hours. Thousands of people they sent thousands of millions of dollars to their account to lose their money. Not only in US, so it happened actually July, in the month of July 15th, and not only that, in the month of September 3, it was BBC News. It revealed that not only their account, similar kind, almost uh, similar kind of message was also reflected in the verified Twitter account of Narendra Modi, who is the Indian Prime Minister. His account was also hacked, and similar kind of message was also reflected there. So, what we I'm talking to you that we need as a result, we need some security, and we need basically the digital security. And here, the cryptography comes into play. Uh, so we all are very much nowadays acquainted with online transactions. So we see many things, and sometimes we order online. You can have a kind of cash on delivery, but most of the cases, sometimes since the companies they give more preferences, or they give more extra facilities or more discount while we pay online. So while we pay online, so there are three persons basically involved. So you, the customer, the guy is the merchant with whom you are actually doing dealing the business, and there is another guy who is the bank. So if you are paying your money using some credit card or debit card or online transaction, then suddenly this bank will come into play, and that bank actually provides you the money, and it gives the money from your account, or from in a case of debit credit card, it gives a credit from your account to this merchant. So now the question is, you have never seen this bank guy or even this merchant. So how do you believe that, who gives you the confidence that okay, to whom you are paying is a good guy, or your money will not be lost, etc. So who is basically giving you the confidence? And you'll be surprised to know that this prime numbers actually provide you that kind of confidence. So in my talk, not today's class, maybe next or next class, I will show you how this prime numbers plays the most important role here. Not only that, so when you use your browser to connect with some other browser, or on other server, for example, suppose you want to search for in Google, you just type my name, then your browser will connect to the website or my website, that may be a presidency website or maybe my ISI web page, or somewhere else. Then how do you know that with whom you are talking is actually the real guy? So who is giving you the confidence that with whom you are talking is actually a real website, or you are not in a kind of trap or something? So that kind of things are basically giving you the confidence, and here also the prime numbers plays the most important role. Not only that, when we use the WhatsApp, so with the popularity of this WhatsApp, now this end-to-end encryption, this term end-to-end encryption is quite common. So when you send some message to your friend using WhatsApp, or when you talk over voice, or even using the video call, you might have seen this kind of things, that your message is being encrypted or is being protected by this end-to-end encryption. So in maybe tomorrow or day after tomorrow's class, I will show you what is the meaning of this end-to-end encryption, and how prime numbers play the most important role here to have this end-to-end encryption schemes. So broadly speaking, I will not be able to give you a full idea of what end-to-end encryption is, but in my master's class, while we take this uh, as a master's course, while we offer this cryptography as a special paper in Presidency University. So there I teach them, or they have a kind of complete project. So what this end-to-end encryption means. So the whole syllabus actually covers the whole end-to-end encryption, because it requires many things, and whatever is there in our syllabus. So end-to-end encryption is a nice example where you can see that all the syllabus of the crypto course is actually involved in end-to-end encryption. For them it's easy to understand, but I will just give you a broader idea. But if somebody is interested, nobody can stop him or her to study end-to-end encryption. So that's freely available online. So anyway, so in every everywhere this in security aspects, this prime numbers plays an important role. So you will be surprised to know that this is a prime number. So it contains 904 digits. If I ask you, really they are prime numbers, so the best thing that you can see that the last digit of this number, so you can see that this is 9. If it would be some even number, 0, 2, 4, 6, 8 something, then you can certainly say that, sir, you are lying, it cannot be a prime number. But since it's an odd number 9, you cannot be very sure that whether this is prime or not. Since I am telling you that this is a prime number, you have to believe, maybe, but you have still some doubt that are they really prime numbers. So in our course for master degree, we have this primality testing algorithm, where I show them by hand that, okay, so these big prime numbers are not a very big deal for us, because my small laptop can also produce this. In today's class, I may show you by using programming how these prime numbers can be produced. But the theory that is behind is, a part of it is within our syllabus, that is known as law of quadratic reciprocity, or the quadratic residues. So that part is within our syllabus, but exact the primality testings are not within our syllabus. But I will give a kind of hints that how exactly they are used. So you'll get a glimpse of idea how these big prime numbers can be produced very easily by using a small laptop or something. So that is quite important for this course, because this number theory, though it looks at the very beginning very theoretical, but it has plenty of applications in our day-to-day life. Okay, so let me then first go have a look at how this internet actually plays an important role in our day-to-day life. So when we get up in the early morning, may not be that early during this lockdown period. So before going for our brush, we first look at our screen of the mobile. And we sometimes put some crazy patterns to open the screen. If I ask you the question, why do we put some crazy patterns or password on our screen? Certainly, the answer would be to hide the information inside our mobile from our parents or from our elder brother or sister, etc. Surely, so something we want to hide from others. So that's why we put some password here. But when the days goes on, then we become very busy, and then we use a lot of things using our mobile. Like we send some message using some official mails to others, we search for newspaper, we buy things, or we see the news. For example, today many people are watching television because it's election results are coming up. Sometimes we do play online gamings. We see our WhatsApp status, or we send some message, or we see the Facebook likes, etc. So many things that we do throughout the day. Not only that, during our relaxation time also, we stay very busy with our mobile. Not only that, at the end of the day, when we go for a sleep, sometimes we stay with our mobile, and sometimes the mobiles they get we sleep with our mobile on our head, but the mobile never stops. Okay. So all those things can be done very easily by using lots of apps that are installed in our mobile. So that's very easy for us because we feel very confident that many things are there, so we can do many things. And the operation of mobiles is so easy that a child can operate it very easily. Nowadays, the childs are very smart. They learn very quickly how to use or how to operate this mobile. As a result, we feel that we are very much confident. We sometimes think that okay, we are very much confident and everything is within our hand. So if we have a kind of statistics, the statistics is little bit older, but I love to have a statistics during this pandemic period. I have a bit, but I'm not going to disclose it now. But it's not a complete picture that I have still yet. So, but I'm searching for the complete statistics of data users. So it's a little bit older data. It's a 2019, so last year's data. It says that Google processes over 5 exabyte of data per day. Now have a look at what 1 exabyte means. 1 exabyte means 10 to the power 9 GB. Can you believe this? 10 to the power 9 GB. So 5 into 10 to the power 9 GB per day. Google handles 1.2 trillion searches every year. So 1 trillion is 10 to the power 12. So Facebook is not far behind. Facebook generates 4 petabyte of new data per day. 1 petabyte is 10 to the power 6 GB. So 4 into 10 to the power 6 GB of data per day. 350 million photos are uploaded per day. Users generate 4 million likes every minute. 4 million likes. 4 millions means 40 lakhs likes every minute. Can you believe this? WhatsApp, nearly 500 million users. It produces more than 70 million messages a second. 70 million messages a second. So now you can think that how big data that every day we all are using. So it's nowadays you can think that now it's that's why this big data is playing the most important role. So big data analysis is very important nowadays, and it's a hot topic now. Many people are going for big data, and many companies actually they are producing or they are actually requiring. So they require a lot of analysis, and here the mathematician and the statisticians play the most important role. So if you have a good computing background and if you are good in mathematics as well as in statistics, then the big data is very good for all of you. Okay. But with all this big data and with all huge amount of data that we consume every day, uh, we have lot of threats. So every coin does have two faces. With this, all this advancement of science and technology, at the same time, we also witness many of the attacks like ATM skimming. So you can see that there is one kind of extra mechanism is being added with the ATM scanner. So when we insert our card, so some extra machine or extra device is being introduced here. So it's done by some attacker. So suppose some of the ATM machines are not protected. That means in most of the cases we have seen that some guard is there. But if the guard is also compromised, then somebody can plug into the machine an extra device. Now, when you put your card here, this card data, so it's nothing but a magnetic chip. So all the data of your card is being copied here, and there is one camera is installed here which is able to capture the pin that you put in. So the pin that you put on the keypad, that is being captured by this camera. So all the data of your card, so this is a magnetic tape. So like previously we used to copy things. Now you can see that the data from, say for example, from one pen drive to another, or the pen drive from your desktop or laptops hard disks, is very easy to copy, and it copies exactly in the same way. So you cannot distinguish between these two. So these things can be copied very easily, and then the pins are also captured. So these things are stored in a device or in a laptop or in a machine which is actually nearby installed. So you might have seen or might have heard about this news that many of the customers, they lose their money from ATM due to this kind of things, and that kind of attacks is known as ATM skimming. So this credit card or debit card frauds are also very common. So I can give you a kind of one very simple story. So it happened around 10 years back in Noida area. So there one guy certainly found that around 80,000 of rupee was taken from his account by using, somebody has taken his from his account by using credit card, but he hasn't used any credit card for withdrawing that kind of money. So when he launched the complaint, the investigation revealed that his phone was not working for last 3 days. So sometimes we find that okay, my phone may not work, maybe the SIM is down or some internal things happen for our mobile. But it happened that for him, the SIM was not working for last 3 days, and the money was gone. See, the card information is not very difficult to get. For example, when we go for, say, filling up the, say, petrol from a petrol pump, so usually when we give the card, so I give the card or we give the card to the third party. So he swaps the card. So during that swapping, is not very difficult to capture the photograph of the card for front page as well as the back side. So because this back side there is a 3-digit PIN number, that is also very important. So it's not very difficult to capture this information as well as the information behind that. And so we feel safe because when we do some kind of transaction, the OTP comes into our mobile. Now the question is, why does OTP usually comes to our mobile? So it's basically a kind of authentication that okay, you may lose your card, somebody might have used your card, but at the same time, the card as well as the mobile is with the attacker is not a very common issue. So it's a kind of, so he may use your card, but at the same time, some OTP comes to your mobile while doing some online transaction. Then you have to put some either PIN or the OTP. So it happened like for him, it was a kind of online fraud. So somebody bought something with his mobile, with his card, and the OTP came. Now you can think that okay, the his phone was not working. Then what happened? Then the investigation revealed that somebody actually launched a complaint to the service provider. For example, suppose mine is a Vodafone, and I go to the Vodafone customer care and maybe the Vodafone mini shop or somewhere, and I may ask them that okay, my phone is not working, please replace my SIM. So what they will give, they will ask for some information and maybe some documentation like Aadhaar card, PAN card, etc. And based on that, they will issue me a new SIM card. If you look at, if you are using your new SIM card, and if you have, suppose you have two mobiles, and you have new SIM card is being issued to you, and if you use the new SIM one, then you see that at the time of activation of your new SIM, the old SIM will be deactivated, even if they have they are in a different mobiles, even if they are the same number. But you see that at the same time, like our land phone, you cannot have a parallel connection. Like you have two SIMs, so you'll get two connections. So with two SIMs having the same number, you cannot use them simultaneously. With the activation of the new SIM, the old SIM actually gets deactivated. So what happened for that guy? Some attacker took all the information about the card, as well as he actually launched and complained to the service provider that his SIM was lost by producing some kind of fake information or fake things. The attacker was able to get a new SIM from the service provider. As so at the time when he was actually buying some things, the fraud actually the buying some things using internet, so he has now the mobile SIM with him. So the OTP came to his mobile. As a result, he could buy the things. That means it actually showed you that your mobile is very important. So nowadays, our mobile is like our identity. So if you lose your mobile, please do not waste you any time to launch a complaint so that all the things could be deactivated. Otherwise, many things may happen with your mobile. Okay. So that was one incident happened in Noida, and so we have to be very careful if your mobile or your SIM card is not working for some time. So you must take care about it. So there is another kind of attack known as phishing attack. So what does it mean? So it's a kind of email that you get. So sometimes you get a lot of emails like spam and all. So it happened usually say 7 to 8 years back. So at that time, many people got this kind of message. Suppose you have a ICICI bank account and you get this kind of message. It says that we are upgrading our system from the bank. We are sending you this message. So please click here. So you have to click here to update your details. So if you click here, it goes into this site. So again, it looks like an ICICI bank details. And there they require your user ID, password, transaction password, etc., and everything. So thousands of customers, they actually put all the information there and they actually lost their money. Why? If you look it carefully here, so this is the address bar. So while doing online transaction, you have to be very careful about this address bar. If you look at everything was fine, ICICI bank dot C0M, it's not COM. So suddenly it's not from the original bank. So it has been sent from some fake account or some fake website. Not only that, nowadays you cannot rely upon HTTP. Nowadays, for secure transaction, it has to be HTTPS. So it was not HTTPS, it was HTTP. So while doing transaction, you have to be very careful at the address bar and you have to look at it should be HTTPS. But always remember that even if your account is HTTPS, that does not mean that you are 100% secure. But if it is only HTTP, then it's almost sure that you are in a trouble. So you have to be very careful while dealing with all those things. And bank never asks from you the user ID and password. I am again giving you another recent story. It's around 1 month back. I got it from cybercrime. So there they reported me that one guy, so he was an engineering student and he is doing his engineering from a decent college, engineering college, but I am not sure how he was trapped. But suddenly what happened, he got a phone call from it was saying that it is from Geo, and his phone number was little older. He was actually using his mother phone number, and it says that your KYC is due unless you put your KYC here, or you have to renew the KYC, or you have to give the details of your KYC. Unless you give it, your connection will be disconnected. So he says that, okay, so I will go to the nearest Geo number shop and then I can give you. They say that yeah, that you can certainly do, but during this lockdown period, you may not go there. We can have this opportunity that you can do it here by online. We can do it. So he says that what you need to do. He said that you have to just pay a 10 rupee registration, and some OTP will go to you, and then that will be done. And all the information you require, you need to just put a kind of fill up a kind of form and etc. And that can be done using online transaction. So for that you have to pay only 10 rupee. So he agreed on that. Then they sent him one link. So they requested that, okay, you just install this software. So he installed that software, and then some OTP came to him and then said that, okay, fill up this form and OTP. He registered that he asked, he was asked to give the OTP, and he gave the OTP to the uh, opposite person, I mean the person who was calling. And then he said that, okay, everything is okay, now pay 10 rupee using online transaction. So he used his VMAPs and all, and he paid, I don't know whether it was VMAP or something, okay, but he used some online transaction method, and he paid 10 rupee, and the 10 rupee was paid, and within half an hour his account was around 38,000 something, and all the money was gone. So he was surprised, and he understood that he was trapped actually. So then I came to know what exactly happened. The software they actually uh, used, that means the software they insisted that guy to install was Team Viewer. So it's a Team TEAM viewer. So you can understand from the name that it's a basically you can view something using a team. So most of the cases, the cyber security guys they told me. So I then search for the Team Viewer software. So you can go for Google and search it for. So it's a basically a software which can be operated from a remote place to your machine. For example, so the cybercrime they told that when they have some problems at their machines, sometimes they say at some remote place. For example, they gave me the example like when Gangashagar Mela. So when some uh, police camps are to be installed there, and suppose they have some person who are having some problem or trouble installing some software and all. So from the head office, they install this kind of software, Team Viewer, so that the whole access of that machine can be accessed remotely. That means from the head office, the officials can have the access of that remote machine. That means everything can be controlled. Like you can see if my machine is being installed with this Team Viewer, and if you send me the access, and if I give you the access, so the OTP was given for that. So OTP was there to access your machine, and that fellow guy, that fellow chap actually gave the access in terms of the OTP. So he has given the OTP to access his mobile. That's why the bad guy actually accessed his mobile, and not only his mobile, they can not only control his mobile, but they can see his screen, they can see his message. So at the time when he used his online transaction payment system, they have seen all the information like his ID, like his code, as well as the SMS that came to his mobile also known to them. So everything what we use for our online transaction was actually with them. So they use this kind of software. So we have to be very careful while dealing with this. It's a kind of joke that happened with me. It's around say 10 to 10 years back around. So one day I got a call from, so at that time it was, so previously it was Hatch for Vodafone, it was Hatch, and then the name came to Vodafone. Okay. So during that transaction period, so at that time the Indian government also told that all the operators should have the KYC of each and every customers and all. So during that time we used to get some phone calls like we are actually updating things, so you need to verify your phone number, who is the account holder, where is your place, etc. So one day I got a phone call from somebody. So during that time I was also searching for this kind of fraud things, and I know many at that time. I had many ideas that how it can be done and all. So I got a phone call and it says that I am calling from the operator. I think it was a Vodafone, and he told that okay, what is your name? So I told my name. So where do you live? Why should I tell you where do I live? So you have all the information with you. They told that yes, I have all the information, but you need to verify. So I told them that okay, the address of my residential place, and then what is the landmark. Then I thought that why are you asking me this question? So I told my name, my place, and all. Oh no, all the things are routine things, so you have to tell me all those things. I told that don't worry, I know. Do you know that I know how to people are cheating others, how frauds are taking place. I give him around 1 minute lecture, and I disconnected the phone call. And they, before disconnecting, they told that okay, if you don't tell me this, then your phone will be disconnected. I will take care of all the things. And then I left the phone, and I was very happy that okay, I at least in a harsh manner I talked with some fraud and all. Then on the next day I saw that my phone was disconnected. So it was actually a phone call from the Vodafone office, and then I have to rush for 3 days to my local Vodafone mini shop, and there I recovered my number. But it was actually a phone call from the Vodafone shop. But really, it's sometimes very difficult who is the real guy and who is the bad guy. But to be on the safe side, you have to be very careful. So while you are revealing something, you have to be little careful that, okay, so you may have to, they may be a real guy, but I think it's better to not to reveal any kind of personal information to the outsider, which may cause some of the problems for your future things, because nowadays everything is digitalized. So it's very difficult to protect all those things. So that's why all the information that if you have should be protected in a nice way. So we have to be careful. Okay. So why I am talking about all those things? Because nowadays this hacking is also very important. This term is quite common to all of us. So you'll be surprised to know that many of us, when we play the online games, and many online games are actually used for online hacking. So if you use this kind of softwares, like most of the softwares nowadays, when you use any of the apps, so all the apps, they actually want the whole control of your mobile. They want to access your message, they want to access your location, they want to access all the contacts details that if you have. So everything they want. Now the question is why they want. So all of them, they want actually the control of your mobile. So sometimes they may be misused, and this kind of games are one of the places where many people actually they lost many of their personal information by using this through online game. So now I am going to give you another very important information. So that was actually a kind of software. So it was a, we call it malware. It means it's a bad software, and the name of the software was Pegasus. So it's a basically a Israeli company. So they actually made this kind of things, and you can see that this Israeli firm, the name of that firm is NSO. So NSO Group. It's not the same NSO as USA, but there it's based on their first name of the owner of the companies. So that name was also NSO, and they prepared a kind of malware that is known as Pegasus. So it's an Indian Express report. It says that the popular messaging platform WhatsApp was used to spy on journalists and human rights activists in India early this year. So it was a 2018 news. Okay. So so this Pegasus was a software that could be installed at your mobile, and through which many information can be leaked. Okay, not only that, it's many things you can see that, but you might have heard about the name of Jamal Khashoggi. So he was actually a kind of journalist and activist also. So his death, so he was actually assassinated, and it has been reported that behind his death, this Pegasus malware was used. So his mobile was actually captured using Pegasus software. The Pegasus is so powerful that usually all the malwares, they can control your location, they can give information about your location, your message. But Pegasus is so powerful that it can open your camera, your microphone. That means without your knowledge, now you can understand that if somebody can open your mobile's camera, then what may happen? It can open your microphone as well. So if you are talking with somebody, what you are talking can be accessed using your mobile. So this is so powerful, and I'm sure that there are plenty of other malwares are available which actually gets a hold of your camera as well as your microphone. So you have to be very careful while dealing with this kind of, especially during this pandemic situation. We have to be very careful while dealing with our mobile as well as speakers and all. So there is another things that you might have seen, that the Indian government has already stopped using, or they are scanning many of the softwares, like many of the applications like WeChat, Share It, Beauty Plus, uh, true callers, etc. So they are basically nowadays Indian government is scanning, because they are actually taking information from us, and they are actually giving a kind of, they're spying on us. So that's very important, that we should take care of all those things while dealing with this kind of softwares. So there is another very important aspect. So I gave actually a project for the master degree students while I teach them this crypto course. So there is a term called darknet or dark web. So you might not have heard, many of you might not have heard about the term dark web or darknet. So that's a very interesting part. Usually, what we use the internet portion is a very small part of the whole digital world. So, whole internet is basically under this dark web or darknet activities. So, what is the darknet or dark web? I am giving you in a nutshell, but not in much details. So, if you are interested, you can study it there on your own, but at your own risk. So what is that? So usually when I use some internet properly, usually there is an called IP address, and that IP address can be traced, and who is sending email to whom. You can understand that. Say if I send some email by using some Gmail, then if the police or the intelligence they want, they can track me. Okay, by using lots of things. There are many things, lot of packet, lot of informations are there encoded in while we send some email to others. But there is a place called darknet or dark web where it's very difficult to identify who has sent you the message or to whom you are sending the message. So for intelligence also, it's really difficult to get information who has sent you the message or to whom you are sending the message. For example, I have shown you the Bitcoin. So the Bitcoin technology also use similar kind of things, that there are few settings are there. If you set in that way, then to whom you are paying the money is very difficult to understand. That's why when they say that, okay, otherwise if you do it like send me a check, then you can understand that to which account you are sending your money. Then you know that which bank, which account number you are sending the money, then you can track the people. But if you are using this kind of concept where it is difficult to understand to whom you are sending the money, then it's really difficult to track the people to whom you are sending. That's why you can understand that many illegal things are happening in the dark web or darknet. In a positive sense, lot of activists, they also use dark web and darknet, because suppose if something I tell openly, say against some government, then the government may take some action against me. But if it is difficult for the government to identify who am I, then it's sometimes easy. So that's why many of the reporters or many of the activists, they sometimes use this dark web or darknet technology to disguise themselves. So that's a, it's a very interesting topic or interesting area. But you cannot access the dark web or darknet. So there is a called Tor or something. So that it's a kind of special kind of browser through which you can access those things. But while using this kind of browser, you have to be little careful, because you can understand that the attackers can access your machine if you are not confident enough, or if your settings are not proper. So you should not go very easily, or you should not go very frequently to that dark web or darknet unless you have some extra knowledge about it. Okay, so it's a different story. But here, what are the among these illegal things? The information. For example, suppose my information. Suppose some hackers hacked my laptop. They actually stole many of the information from my laptop. So what they usually do with this information? Most of the cases they use for their own sake, but sometimes they sell the information in this dark web or darknet. So if you go to the darknet or dark web, it's a kind of bazaar, it's a kind of marketplace where you may see that some people's information are being sold. For example, his email ID, his bank account, his password, etc., is being sold in some sites. So you can buy things; they are very cheap. So you can buy things and then you can try hacking them and etc. So it's a kind of place where some illegal things you can find. So nowadays, you in India also, you might have seen that lots of high-end cars are available. For example, BMW, Ferrari, maybe Mercedes and all. And why they are very costly? Because they are of course luxurious car, but to get the kind of comfort or to have the more efficiency, the car company has introduced a kind of small CPU they have installed inside the car, so that all the instrument or all the parts of the bodies, they can communicate with each other using that computer. So that is a kind of small CPU is installed with that car. Now it's the research says that this car, this small CPU can be hacked, and if that is hacked, then the control of the car can be done, or can be remotely accessed. That means even if the car has a driver, the control of the car may not be with the driver. For example, somebody from outside may control the speed, direction, screen up, down, etc. Anything can be controlled, since they are fully automatic car, can be controlled from outside, and that's a horrible situation. Now you can understand, if you are driving a car whose control is not with you, then what may happen with that car. Again, this is a kind of very shocking news. It says that the pacemaker, so usually when somebody is not well with his heart, so usually for elderly people whose hearts are not working properly, then some extra instrument we sometimes install. So it's called pacemaker, that actually helps the heart to properly pump. This says that for high-end pacemaker, there is one CPU. So one computer, small computer is installed to sense the pulse of the heartbeat. And it says that, this report says that that small computer can also be hacked. Now you can understand, if that is hacked, then what may happen. So the control of the computer can be, small computer can be done from a remote place, but it says that don't worry, you cannot be far away, like you have to be within 100 meters of the patient. That means you cannot hack or you cannot control the heart from a far apart, but you have to be within 100 meters radius of that patient. But that's quite shocking. In India also, we might have seen the smart houses. For example, smart TV, smart television, smart door, smart kitchen, etc. You might have seen that Amitabh Bachchan ji is trying to control the room temperature of his home from a very far apart. So this kind of things are known as Internet of Things. You might have also seen the advertisement that one guy is actually instructing his through the mobile that I am coming to home, please make coffee for me. Then when he reaches home, he finds that his coffee is ready, because he calls his mobile using some kind of Alexa machine, and this Alexa machine communicates with the coffee machine, and coffee machine gets on and it prepares hot coffee for him. So when he comes back his home, he gets the hot coffee. So that kind of things are nowadays available even in India also. But you can understand that if the control of the whole home is gone, that means somebody, you can communicate with each other, each of these devices using internet. Now if that control is being gone, then you can understand what may happen. The whole lighting system, the door, the kitchen, the gas, everything could be controlled from outside, and that could be a horrible situation. This is in a bigger perspective. This is known as cyber terrorism. So this is cyber terrorism. What does it mean? This says that in a bigger sense, you sometimes might heard about many of the machines all over the world are not working, or they are under risk of some virus. Many of the viruses are there, but in 2017, only 3 years back, during May 12 to 15, only for 4 days, the biggest cyber crime attack happened on the all over the world. That is known as WannaCry ransomware attack. What it says, in certain morning you might have seen that suppose my machine is being hacked or attacked by this WannaCry ransomware attack, then when I switch on my laptop, on the screen this thing will come. It says that don't worry, all the information of your machines are intact, just pay through this Bitcoin this amount of money, then I will give you the key to open your laptop. That means all the information of my machine are being encrypted using some key. So unless you pay that amount of money using the Bitcoin, they are not going to provide me the key, and I cannot operate other things. But if somebody will ask me to do so, I will say that don't worry, I have enough backup with my machine. I will just format the machine and I'll get back all the information. But just what will happen for some multinational companies' main server? A few days back, just maybe last month, I have seen one news that Haldiram's Haldiram's main server was actually hacked with this ransomware attack. But it was just 1 month back. Huldiram's main server was actually attacked with this WannaCry ransomware attack, and they were claiming around 7.5 lakhs rupee to get the key back. Now think about some multinational company. So usually this multinational company's main server, they have some backup, but if that is being hacked and they cannot actually declare it publicly, because if say for example, if some company, for example say SBI, if SBI's main server is hacked, then SBI cannot publicly tell that their main server is hacked, because if they tell like that, then their share price will suddenly go down very quickly, drastically. That will go down the share value, because people will say that, okay, how can you protect our money? So that would be a kind of thing that happened with most of the multinational companies, and within 4 days, thousands of companies, they actually gave billions of dollars of money to the attackers. So only within 4 days, you can see that this is the corona, like corona map. So it's the red portion actually shows you where this ransomware attack happened. And it also happened in India as well. I got some news that in India it happened with some of the, in West Bengal, some of the police stations it happened. I don't know why it happened to the police station, but it happened. And it's like a corona map. It's all over the world. The people all over the world, they witnessed this ransomware attack. And I'm sure in near future we are actually expecting much bigger cyber attack. So the question is what to do. So one simple answer could be we can stop using internet. So everything is happening because we are connected through internet. But if we stop using internet, then nobody can get into my machine, and then we are done basically. But if I ask you the question, is it really possible to stop using internet? What would be your answer? So your answer will certainly be no, you cannot stop using internet. So what we require a secure digital world, and here the term cryptography comes into play. So if you look at, I wrote it here less fear. I could have write it like fearless. So fearless and less fear, they are not the same thing. That means that is not commutative. So less fear means you have some fear, but the fear is less. So somebody may say that, okay, I use antivirus, so what could be my fear? But it would be very difficult to make you understand that sometimes the antivirus company, they produced viruses. So for the cell, or so they always they deal with viruses. So they know very much what is the nature of virus. So to increase the sales, sometimes they produce on their own some viruses. So you cannot say that even if you have some antivirus, you are very much safe. So we have to be little careful while dealing with this kind of things. And here I must say that it's better to use Linux instead of Windows. So unless you have a original Windows with a updated version, so it updates. So you can understand why Windows, they keep on updating things, why Linux, they keep on updating things, because every day people are trying to make lots of virus, lot of cyber threats onto it. And when they produce some virus, the companies like Microsoft or Linux, they actually try to overcome or try to understand what are the loopholes that they had into their system. And when they found, when they fix up that problem, they upgrade their system. So unless you upgrade your system, you cannot be very secure. So you cannot be very confident that nobody can hack your machine. But even if you update your machine, then also you might have some problems, because the new, sometimes the new virus, they, when they affect your machine, then also you may be under threat. But if you do some updating, then it's really helpful for your machine to be protected. Otherwise, it sometimes, for the WannaCry attack actually happened to the Microsoft machines, and mostly those machines which actually a lack of updation. So for those machines, actually the WannaCry attack happened. So now you can see that there are mechanisms how to stop this ransomware attack and all that. So you have to be careful while putting your machines or while choosing your settings of your machine, so that you can stop the attack of ransomware on your machine. So that things are already there. We have to be little careful while we are dealing with this kind of software. So the question is, what is cryptography? So till now, what I have given is a kind of just an introduction, why this kind of things are useful. Now I am within the syllabus things. So till now, whatever I talked, is there any question or anything that you want to talk or you want to discuss? So you are welcome to comment anything you would like to discuss. So if you have any question, please
Sir,
don't
can you
hesitate.
please elaborate on Bitcoin? I don't have much idea about Bitcoin.
Okay, so Bitcoin I cannot elaborate because it's a, as a whole is a topic. So the basic idea is, usually when we use our credit card or debit card, you can understand the three things are important, like the customer, the merchant, as well as the bank. That means you cannot pay directly to the merchant without the intervention or without the involvement of the bank. So the bank will certainly charge a bit from you. So it will charge a bit from you as well as from the merchant. So that's the income of a bank. Now people thought that why not we should have a world where the business will be in between only the merchant and the customer. There will not be any third party who will intervene or will involve within that business. So from that idea, they came up with the concept of Bitcoin, where Bitcoin is a kind of direct transaction from the from the merchant or from the customer to the merchant. That's why you can understand, if there would be any bank in between, then through that bank, somebody, the intelligence or the police, may capture the bad guy. But since there is no third party involved here, it's a directly from the sender to the merchant. It's difficult to get who, to whom you have sent this money. So if your setting is like that, you can disguise yourself, then it's difficult for the intelligence also to get the information that to whom you are sending the money. That's why there is no concept of bank here. So it's a, if from a positive sense, it's a good that there is no centralized body. For example, in India, everything is regularized by RBI. So suppose if you want to overcome or something, you don't want the involvement of RBI, then you cannot do anything here. So in India also, and in many other countries, the Bitcoin is not yet legal. That means in India, you cannot use Bitcoin. You can use Bitcoin, but for Indian transaction, you cannot use Bitcoin. But in Japan, in US, in China, so they are the basically kind of miners. So to understand Bitcoin, there is another term that is very much important, that is known as blockchain. So you have to also understand the topic blockchain, but that is the idea, basic idea of Bitcoin, how it is used. Or so if you look at the history of Bitcoin, so who is the inventor of Bitcoin is not exactly the known. So you know a name that he is the guy who invented, but who is that guy is not known. So somebody says that he is from Japan, and somebody says that he is from China, and it's a kind of not very clear who is the actual guy. But when it was invented, the price of a Bitcoin was around maybe a good pizza. Say a good pizza, it cost around, say I can say that in 1,000 rupee you can have a very good pizza with a regular size. But if you look at now, somebody will tell me, can somebody tell me what is the today's price of one Bitcoin? One Bitcoin is equivalent to how much money in Indian rupee? Can you very quickly, can somebody give me this idea? One Bitcoin is how much Indian rupee, Indian currency? So when it was invented, it was, say, maybe I can say that one good pizza maybe 1,000 rupees. Yeah, how
Around
much?
around 11 lakhs.
So 11 lakhs. So 1,000 to 11 lakhs. Can you believe this? So one Bitcoin is in today. So it varies like every day's share market. You understand that in share market the price varies. Here also the Bitcoin price varies. So now one Bitcoin is 11 lakhs. In just Google, you can, if you type one Bitcoin is how much Indian rupee, you will get the answer. If you collect this information today and if you collect tomorrow, then you'll find that there is a change in price list. So it's a kind of share market things, and many people use it for share market, and Chinese, they are very good. So there are something called miners who are actually producing this bitcoins, and they are getting some incentives, and so that's a kind of things that it depends on the company to company, country to country. There are some rules and all. So I mean, broad way, I can explain you that way, but in a so there will be in coming December 21st to 23rd, I am organizing one international conference. So there, the first speaker will speak on Bitcoin. So if you are interested in, so please be there. Then you will get at least some idea about Bitcoin. Okay. Okay. So any other questions or queries? Anybody?
So you said earlier about HTTP and HTTPS. So who provides the security to the websites?
No. Okay. So HTTPS is a protocol. It's not like who. Okay. So it's a protocol, and then this, for example, suppose HTTP, you are using HTTP and HTTPS. For example, I have an website which is little bit old, or I want to have, and it is hosted, say, for example, say BSNL one website. Okay, so there are some service provider, for example BSNL. Nowadays, if you do this, so they don't allow it to use HTTP. So it's mandatory to use HTTPS. And there is a concept called certification. So at the left end of your browser, if you look at, there is a called certification. So if I am a service provider and I want to have a kind of website, so I should have a certificate. So that is known as third party certification. So trusted third party certification, who provides you a certification. So there is a called deadline. So sometimes when you access some of the websites, your browser stops connecting with it. It says that please have a look at the certificate. So sometimes the certificate dates are over. That means it says that, okay, I validate you for 1 year. So after 1 year, I have no guarantee. So a third party gives you a kind of confidence to the users that, okay, for 1 year, I give you the warranty, that guarantee that they are not fake. So a third party, trusted third party is there. This is known as PKI, public key infrastructure. So I will explain a bit about all those things when in my succeeding classes, but not in details. Of course, it's an introductory course. So there you will understand what is PKI and who is giving you the in my so not in my slide, it's not there till. So there is a one slide where I show you how this PKIs are important, but for that you have to know what is public key cryptography. So in my course, I will show you the idea what is public key and how prime numbers are important. Okay. So any other question? Okay. So if not, then I will go little beyond about what is cryptography. So cryptography is a quite old topic. So it came from the word Greek words, two Greek words. Cryptos means hidden and graphia means writing. So cryptography means the art of writing secret message. Okay, so suppose two guys A and B, they want to communicate with each other in such a way that if A sends some message to B, so B should know some extra information. Using that, he can get back the information what exactly A sent to him. But if any third party, say opponent, gets that message, the information that the opponent has won't be able to get the original information about the original message that A sent to B. That means if A sends some message to B and say A sends some message to B and B is the opponent, so say M is the original message. So he doesn't send this original message to B. What he does from M, he converts into a message called C. We call it ciphertext. I will come into details. Then he sends ciphertext to B. Now, if opponent gets the ciphertext, he should not be able to understand what is M is. But B might have some extra information using which we call it K, the key, using which he gets from C, he converts it into M, which was the original message that was sent from A to B. So that was the idea of cryptography. That means opponent will not get any information about M from C, but the designated person to whom A actually sent the message, since he has some extra information K, he will be able to get the information from C to M. So that is the idea of cryptography. Okay. So few important terms which are very much useful for cryptography. So there is one guy who is the sender and he is the recipient. Suppose he sends this message using some internet technology. The problem is a bad guy is there who is trying to listen what is being sent. Not only that, this bad guy has such a power that he can modify the information. Suppose he has sent some message to this girl, he modifies this message, and as if when she will receive this message, she will understand that that modified message was actually sent by this sender. So it could be a kind of misconception or miscommunication. So this boy, the sender, has to be little bit more careful. So the original message that the boy wants to send to this girl is known as plain text. So they are now cryptographic terms. So now we are within cryptography. So plain text is the technical term which is known as the original message that the boy wants to send to the girl. Now, if the boy wants to send the plain text to this girl using this internet, then this bad guy will come to know the plain text. So that is not wanted by this boy. So what he does, he used some lock and key technique. So he used the plain text and he locked the plain text to get another text which is known as ciphertext. So ciphertext is the locked message. So he sends this locked message through this internet to this girl. Now, the process through which plain text is being converted into ciphertext using some lock and key or the key is known as encryption. So, encryption is nothing but a mathematical function which converts the plain text into ciphertext using that key. Now, this ciphertext is being sent. So, ciphertext is nothing but the locked message. Now, this ciphertext is sent to this girl. Now, when the ciphertext is being received by this girl, she will use a key to reopen or to unlock the message. So, the process of unlocking this message is known as decryption. So, decryption is nothing but a mathematical function which converts the ciphertext into plain text using that key. So, this is encryption and this is decryption. So cryptography is nothing but the process of encryption and decryption. So a mathematician or a statistician or a computer scientist or somebody or scientist is trying to construct a scheme. So this is known as a constructive scheme which consists of encryption as well as a decryption scheme. Now, like this bad guy, there are many other bad guys also who are always trying to listen what is being sent or trying to find some loopholes of these cryptographic schemes. That means they are trying to find some loopholes or weakness of the scheme, or they want to get the plain text information from the ciphertext. This process is known as cryptanalysis, that is the analysis of the cryptographic scheme. So this is known as cryptanalysis. And these bad guys are known as adversaries or attackers. So adversaries are nothing but these bad guys who are trying to get the information. Now, I am telling that they are bad guys, but they are basically relative things. For example, suppose uh, Pakistan is talking with America using some secret channel. Now, some Indian intelligence guy, they intercept this message and they try to get the information about the what is being talked. Now, what do you think? That this guy is a bad guy or a good guy? So you certainly, being an Indian, you will certainly say that no, he is a good guy. He is trying to get information which are being sent from Pakistan to America or America to Pakistan. So it's basically a relative thing. So nobody is good or bad. It's the point how you are looking the whole thing. So somebody, you can think that he is doing the constructive things for a bad guy. To you, it a bad guy, but to somebody, he is a good guy. So it depends on the how you are looking. So anyway, cryptography is basically consists of two things. One, you can say it's a constructive scheme that is known as cryptography. Another is known as cryptanalysis, which we call destructive things. So in a broader topic, we call it cryptology. So cryptology is a broader topic which actually consists of two things. One is cryptography, another one is crypt analysis. So in cryptology, we have basically two important primitives. One is symmetric key, another one is asymmetric key. Now here look at, these two keys are very important for encryption and decryption. If these two keys are same, then we call it symmetric key. That means if both the senders as well as the users, they use the same key to open the message, then we call it symmetric key. Now if it happen to be, if two keys are happen to be different, then we call it asymmetric key. In our course, I will give you few of the examples of symmetric key as well as asymmetric key. So both of few schemes are within our syllabus, and I will discuss in details how they are made. Okay. So few examples like AES and RC4, they are not within our syllabus, but for asymmetric scheme, RSA and ILGAMAL, they are within our syllabus. But for our master degree course, they are within the syllabus. But for this course, I'll discuss about few symmetric keys, which are, I will discuss, they are historical symmetric keys, and the RSA and ILGAMAL, they are within our syllabus. So they are asymmetric key crypto system. Okay. So now give us some of the examples. Mostly they are historical examples. So they are examples of symmetric key cryptography. So this is actually used around 5th century BC. Now you can understand that 5th century BC. So it's a before Christ and also 5th century. So it's known as Spartans. So usually you know that Spartans are very much fond about wars and all. So they used to send message using this Spartan Skytel cipher. What does it mean? So here, it's a kind of you can think of this is a kind of bamboo or something like this, and so papyrus papers were actually wrapped over this. So you have a strip of paper, and this papyrus paper are wrapped over this. Say this is a bamboo, small bamboo stick. Then write something on it, okay, and then unwrap it. So first roll wrap over, say a small strip of paper is there, a small bamboo strip is there. First you roll the small paper strip over the bamboo strip. Now write something on it. Okay. So after writing, you just unfold it. So what you have a small strip of paper and some writing is there. Since you are writing row wise, while you unwrap it, the letters will be in a different frequencies and different places. That will be you cannot read it like this. When you see in a paper, it will be like a straight strip of paper with some alphabets, but you cannot really understand what is being written. Now what they did, they sent this message, the strip of paper, to the others. Now both of them, they will have a similar strip. Okay. Now when the enemies will get this strip only, from there it's really difficult to understand what is being done or what is being written. But when the person to whom you want to send the message, if he has the similar bamboo strip, then he can just wrap it and then he can understand what is being written. So you can do it by using your pen. Suppose you have a pen, or if you have the whiteboard pen, then you can wrap it over this and write something. And when you unfold it, you see that there will be a lot of writing over there, but it's really difficult to understand what is being there. But if you think in a mathematical way, then it can be attacked easily. Any idea? Do you understand what is the scheme? Do you understand what is the scheme that I explained now? Any question? The scheme that I mentioned now. So it's a small strip of paper and then wrap it over some bamboo stick, then write it something. After writing it, just unfold this strip of paper. Then a strip of paper is like very thin and all the things are in column now. So using matrix theory, you can attack it very quickly. Now, in my next class, I will ask you how to attack it. Okay. So, so that's a kind of homework you can think of, that implement this Scatile ciphers, pattern Scatile cipher. Just type on the Google, you will find in details, and then implement it. In my next class, show me how you have implemented this, and then find an attack strategy. Suppose you are an opponent or you are an adversary, you have the strip of paper. Now you try to guess what is being sent, what mathematical things or what mathematical objects that you use it. I'm telling you, matrix may give you a kind of hints that using matrices you can understand what is being sent. Okay, so that's a homework. Okay, then another stream is known as Caesarian cipher. It was again used in 50th BC. So it's quite interesting. Now you can understand that it was before Christ. So more than 2050 years back it was used. So it was amazing. So what was that scheme? Suppose Julius Caesar wants to send some message to one of his subordinate. Okay, but the problem is the subordinate is say fighting in another battlefield, he is fighting in another battlefield, they are far apart. But before going to battlefield, they have decided that okay, they are going to use k equal to 11. That means for future message communication, they are using k equal to 11. So this k equal to 11 is the key. So let us try to show you how k equal to 11 is being used. Okay. So suppose Julius Caesar wanted to send the message cryptography is fun. Now k equal to 11 he has used, and Julius Caesar knows that this value k equal to 11 is also known to the subordinate to whom he wants to send the message. That means both of them, they are using the same key. Now this message cryptography is fun becomes this. Suppose by using k equal to 11, Julius Caesar made this. How he is making it, I will explain you later on. But suppose k equal to 11, cryptography is fun becomes this. Now this is being carried by some carrier. So he will go to the place and he will give this information or this message to the subordinate. Now the subordinate will receive this and he knows the value k equal to 11. Mind that the carrier doesn't have any idea about k equal to 11. But before going to the war front, Julius Caesar and his subordinate, they decided upon k equal to 11. So both Julius Caesar and his subordinate, they had the idea of k equal to 11. So this is the ciphertext that the subordinate will receive. Now from that ciphertext, by using k equal to 11, he will get back the original information. So let us try to explain how it happened. Now, suppose I assume that Julius Caesar used English alphabet, though he was a Roman, so he used to use Latin alphabet maybe, but for the sake of simplicity, let us try to explain the whole thing using English alphabet. And I assume that only uppercase alphabets were used. So we know that A to Z, there are 26 many alphabets. So we call it 0 to 25. Okay. So it's a kind of roll number. Now cryptography is fun and k equal to 11. What does it mean? Say C, the roll number of C is 2. Now what Julius Caesar did, just shift 2 or C 11 times to the right. That means C means 2, 2 plus 11, it becomes 13. So 13 means N. So replace C by N. Now similarly, what is R? The roll number for R is 17. Now 17 plus 11 is 28. But 28 will come here, but because of it's 25, nothing is there. So the question is what to do? Just cyclically shift it. So 26, 27 and 28. That means R is nothing but 2. That is C. How do you explain it mathematically? Is 28 just divided by 26 and what would be the remainder? That is C. That is 2. 28 divided by 26 and take the remainder and that is 2. So that's why it's coming cyclically. So that's how this cryptography is fun becomes this. Now this will be carried out by the carrier. Now when the carrier will reach to the subordinate also knew the value of k equal to 11. What he did, so n is here. What he did, he just left shift all the information cyclically. So n means 13, left shift means subtract 11. That means 13 minus 11, that becomes 2. So this becomes C. So R is here and subtract 11 times and you will get all the information and so on. So this is C 11 times left cyclically. That means you will again get back to R. That means 17, you will get R. So the information could be found out. Now if I ask you the question, as you know the group theory, as you know the ring theory, number theory, how will you explain the whole thing by using group theory? Any idea? That can you explain the whole scenario using group theory? See, I have already shown you kind of introduction about group theory and all, where I have shown you this, the group theory, the formal definition that we have today, the axiometric definition usually came around 1870 and all. So it was BC, so more than 2050 years back. So I am sure that Julius Caesar had no clue about the definition of group theory. So he did it in a different way, in an indigenous way. Now, being a student of mathematics, now my question is, how will you explain the whole scheme, the encryption as well as the decryption scheme using group theory? So any idea? Can you explain a bit? How will you explain? Any idea? Okay, so let me explain. I'm giving you an hints. So this was a kind of device that was actually used during that time. So it's a basically it's a center and you can rotate things, but it has it has two parts. So you can rotate keeping this fixed you can rotate this one keeping the outer circle fixed. Now, depending on the situation, for example, A goes to N. In our case, A goes to P goes to N, right? So that means 11 times shift, whereas this is A goes to N. So A goes to N means the key was, can you explain what was the key? A goes to N, A goes to N. That means K equal to 13. If I use K equal to 13, then this is the instrument that was used. So what they did, they just shift it like this. How many times that they want to shift? So it's a right shift 13 times. Then keeping this fixed, you can rotate this inner circle and make it N. Then you can understand that if what is the your plain text, the plain text alphabet will be this, and this will be your ciphertext. Then the B will be replaced by O, C will be replaced by P, and so on. So that kind of things were used. Now if I try to understand it mathematically, then the group theoretic techniques are used. I am giving you again a hint. So this is the hints of the thing that this is related to our group theory, and this is related to a cyclic group. If I ask you the question, from our very childhood, we are looking at the clock. If it's a normal clock, it's a 12 digit clock, then have you ever asked you the question, what is the time 13 o'clock? Usually we don't call it 13. The 13 means it's 1. Unless you are in a airport or railway station, it's only 12 digit clock. So whenever we have say 13, that means it's 1. So after 12 we come to again 1. So we can think of this is nothing but a cyclic group Z12, where 0 is nothing but this 12. So everything is same except this 0 is nothing but the 12. So this is the example of a cyclic group. That means we are very much strong from our childhood about the cyclic group. So we know many things about cyclic group. Okay. Now you can explain very easily the encryption and decryption function. So here the plain text and the ciphertext and the keys, they are all from Z26. So the set of all plain text are nothing but A to Z. Now you can understand the ciphers are also from A to Z, and the keys are also from 0 to 25. Okay, so you can think of all the plain text, ciphertext, and the key space are from Z26. Now this key value could be anything from 0 to 25. If the value of k equal to 0, that means you are not shifting. That means the plain text and the ciphertext are the same. So what is the encryption? Encryption is nothing but x plus k modulo 26, or you can think of this is x plus k class. What is the decryption? This is nothing but y minus k. So y minus k is nothing but the left shift cyclically. That will give you the decryption. Okay, so this is understood. Now if I ask you to play the role of an attacker, so suppose you have this message with you, and suppose somehow you know that the message actually came from Julius Caesar. So Julius Caesar sent you this message, suppose you come to know, and you know how Julius Caesar make the scheme. So how Julius Caesar made that scheme. So you know all the information that he ships. The only thing that you don't have is the value of the k. So you don't know the value of the k, but you know that how Julius Caesar made this scheme, how Julius Caesar prepared this scheme. So you have the ciphertext. Now if I ask you the question, how will you decrypt this? So how many steps, how many maximum steps that you can take so that you can get the information back? Any idea? Any idea?
Said 25 steps.
Yeah, so mathematically speaking, it should be 26, because 0 you also have to take care of, because the value of k is actually from 0 to 25. That means
We
there are
try
25.
25. For the last, we don't have to try.
Yeah, but say you don't have to try, but mathematically it may happen that Julius Caesar has used k equal to 0. Might have. That means he has sent the plain text. You are assuming that k should be greater than equal to 1, but it may happen mathematically that the value of k could be 0. That means you have to.
I'm not assuming that it is greater than zero. I'm assuming that it could be zero, but if we try 25 steps, the last step would be followed by the first 25 steps.
Followed means.
Followed means if we check from 0 to 25 and it is
Yeah.
not in this list, then it should be obviously 26.
Yeah, so see, 0 to, you are checking from 0 to 25. That means you have already tested 26 steps.
24. No, I am checking from 0 to 24. If it is not in the range in 0 to 24, then it is obviously 25.
Yeah, but you have to check, right?
Yes, yes, sir.
So, yeah, so in that way you can make a betterment of this, but for the, yeah, so that could be a betterment of your algorithm. But since mathematically we are taking the value of k from 0 to 25, so naively speaking, you have to check 26 steps, around 25 steps. What you are taking, telling is correct. Yeah. Okay. So that means you are basically taking all the values of k. So we call it exhaustive search. That means you are doing all possible checks. So first you take about k equal to 0, k equal to 1, k equal to 2, and then k equal to 25. This is known as exhaustive search to have a look at all the possible cases. So now you can understand, since the value of k is less here, so only 26 options, using computer you can do it very easily. So one homework could be those who have already acquainted with the C programming, they must have this encryption decryption scheme of Caesarian cipher, as well as they should have an attack strategy. That means they get some message from the Caesarian cipher. Now suppose that is their cipher, now they don't have the option of k, so they have to run it for 25 or 26 times, and from there they should tell me that what was the original message. So it may be meaningful, it may not be meaningful, but among these 26 messages there should be at least one. Now it may happen that two messages happen to be meaningful. So from no information to two information is quite significant. So you didn't have any information, but you get two meaningful information. So you have to be careful. For example, suppose it happened actually in it happened in World War II. So this is a kind of techniques. So Japanese, they actually put lots of sent lots of their aeroplanes, the fighting jet planes, to some places, and suddenly the intelligence, they captured some message. Whenever they captured a kind of ciphertext, they found that usually the fighter plane, they come and they bombed, they dropped lot of bombs, and sometimes they get another kind of message, ciphertext, where they found that the fighter planes, they came but they didn't drop any bomb. Okay, so from that they understood that ciphertext, two types of ciphertext they received. One type of ciphertext they understood from the physical phenomena, that if this ciphertext will come, then the fighter planes will come and they will drop bombs. But another kind of ciphertext they received, if they got that kind of message, then they understood that the fighter planes will come, but they will not drop any bomb. So that kind of idea, so it's very important that how much information that you are getting. So from ciphertext, they couldn't break the scheme. They are not able to get any arbitrary message to decrypt. But from that message, from two ciphertexts, they understood, they distinguish that okay, when we receive this message, we may not be of that threat, but we are in a threat when they receive the ciphertext that they understood that that corresponds to the falling off or the charging of bombs or something. So cryptography is very important in that way. So it's not always that you can always decrypt the whole ciphertext. Sometimes it happened. It also happened for our for the incidents for Bombay Stock Exchange explosion. So that you all know. So it happened that Indian intelligence got that message, but they could decrypt it after the incidents. If they could have decrypted it earlier than the incidents, then that incidents could be stopped. And we'll be surprised to know that Indian intelligence they actually diffuse many of such incidences, which usually we don't get any information about it. Sometimes you might have heard about that in the airport, some red alert were given. So when you think that okay something may happen, but usually what they get some information, they decrypt it, and they find that something may happen, and to be on the safe side they put red alert on the some important zones and all. So that's why it's not always very important. For example, suppose some intelligence they got some message, a big ciphertext say of one page, and from their ciphertext they could decrypt part of the things like a date, a time, bomb, explosion, and say a place name. Then they don't require to decrypt the whole message, and it's really not possible practically to decrypt the whole message for the intelligence. So sometimes what we do is basically we do a part of it, not the whole of it. And if you get partial information about the incidents, then it's sufficient for most of the cases. And that is actually the practical way, because you may not have that infrastructure, that time to decrypt the whole message, but a partial decryption is sufficient to stop lots of such incidents that are happening in today's day world. Okay, so it's a kind of exhaustive search that's sometimes very much important, but you understand that since it has only 26 options, so it's very easy. So one of the tries for a good cryptographic scheme is to increase the key space. So here the key space is the all possible sizes of the keys. I mean all possible choices of the keys. So here only 26 choices are there. So you can think that okay, by some way if we can increase the choices of the keys, then the scheme will be more secure. Okay, let us try to have another scheme. This is known as affine cipher. So I already talked about group of units. So it's based on group of units. Okay. So what is that idea? So here the plain text is basically the original message X, but here the key is an ordered pair. So it's Z26 cos Z26 such that GCD of A and 26 equal to 1. Okay, so it's a key is an ordered pair. So in my previous case the key was only from Z26, but now my key is from ordered pair such that the GCD of A and 26 equal to 1. Now the encryption is like this. Encryption is AX plus B modulo 26. So encryption of this X is nothing but, so here K is AB. So encryption of X is AX plus B modulo 26, and decryption is nothing but A inverse Y minus B modulo 6. Now, if you put uh, XY belongs to Z26, okay? Now, if I ask you the question, what is the size of the key space? So, what is the size of this key space? What is the cardinality of this K? Can anybody will tell me what is the cardinality of this K?
That 26 square.
No, it's not 26 square, but you are in a right direction. But have a look, extra condition is there.
Oh, okay. Sorry.
So what is the size of K?
Sir, 26 into 526.
26 into 526. That means 26 into 513 means 12. So 26 into 12. Okay. So this is an example. For example, suppose you take k equal to 73. Then why I have taken this GCD of a and 26 to be 1? Because I need to put a inverse, right? So when a inverse will occur when GCD of a and 26 to be 1. Unless you have GCD of a and 26 equal to 1, you cannot have the multiplicative inverse in Z26 star. Okay. So you know what is Z26 star? So group of units with 26 elements. Okay. So now you can understand. So if my key is this, so both the sender and the receiver will have the same key. Suppose your message is M. How you can do this like this, and how to decrypt this? The decryption is very simple. This, so you will get the message back. So this is now you can understand that previously I had only 26 many options for the exhaustive search. Now if somebody wants to attack this scheme, for exhaustive search, he has to search 26 into 13 times. That means the size of the key space has increased. Okay. So you can think of the previous one. This scheme could be a betterment of your scheme. Now, can you tell me that is affine cipher a particular is a generalization of Caesarean cipher? Is the affine cipher a generalization of a Caesarean cipher?
Yes, sir.
How?
For the Caesarean cipher, we are taking a equal to 1.
Yes. So if you just put a equal to 1, then 1 comma b, you can consider 1 comma b, then that is nothing but the key for the Caesarean cipher. See, if we put 1 here, then this is x plus b and this is y minus b, same thing. So affine cipher is nothing but a generalization of a uh, SIP cipher. Okay, and here the size of the key space has increased. As a result, you can think that this scheme could be considered to be a better scheme than the previous one. Okay. Now I will come for today's class. The last scheme that I am talking about is the scheme known as permutation or the substitution cipher. So we all, many of us, we are fond about Rubik cubes, and you will be surprised to know that this with the Rubik cubes, every steps you can associate with an element of a permutation group Sn. So it's a basically nothing but a permutation. And if you have a look at the laws or the golden rules for this Rubik cubes, the proofs are there. There are many theoretical bounds are there that what could be the minimum possible steps so that from any state you can come to the identity step. That means all the color matching, if we call it that identity step, then every move actually induces a permutation of some Sn. Okay, so that's a different issue, but those who are fond of Rubik cubes, they also should have a look at the theories behind it, and then they find that it's an interesting theory of permutation group. Okay, but using that permutation, we can have another scheme that is known as substitution scheme. So what is that scheme? Suppose my plain text is from A to Z. Okay. Now I want a scheme in which suppose I want to define the ciphertext. How? Wherever I will get A, I will replace it by D. Okay. Wherever I will get B, I will replace it by F. Wherever I will get C, I will replace it by H, and so on. So wherever I will get X, I will replace it by Z. Now I did it in such a way. Can you tell me, is it possible like A goes to D and say F also goes to D? Is it really possible? Say A goes to D and F goes to D. Is it really possible for my encryption scheme?
No, sir.
You can say that okay, it's not possible, because otherwise if I get D as my ciphertext, then I will have a confusion where to go back, whether I go back to A or I go back to F. So that could be a confusion. So that's why each of this alphabet should go to a distinct alphabet which are not used earlier. So that means you can think of this as a permutation. For example, if I put A to Z as 1, 2, 3 to 26, then A goes to D means A goes to 4. So you may not see this is very smallly, I mean, it's written in a very small way, but it's a permutation where I have written 1 goes to 4 because 1 goes to D. So B goes to F. What is this value of F is 6. So 2 goes to 6 and so on. So this encryption key is nothing but a permutation on 26 elements. So if I want to convert like cryptography is fun becomes so C means H, so H R is nothing but Y, so R is Y and so on. Now if both the sender and the receiver they share this permutation, then it's very easy for them to get back. Suppose you get D, you can suddenly replace it by A for the plain text. Now if I ask you the question, suppose you are an attacker and you have only this message and somehow you come to know that this scheme is being prepared by using substitution cipher. Now how many guesses that you have to do? For example, in case of Caesarean cipher, you did it only 26 options. For affine cipher, you did it 26 into 13 options. Now, if I ask you the question, how many options that you need to get back the plain text if you have this? So this is a particular one, but in general, suppose you have a ciphertext from substitution cipher and you know everything like it is being done by substitution cipher and you know how the substitution cipher is made. But if I ask you the question, if you don't have the permutation, then how many options that you have to, so it's a 26 factorial. Very good. So it's 26 factorial. Now, any idea is how big is 26 factorial? This is this. So I already explained the question like at the end of 26 factorial, how many zeros are there? In one of my previous classes, I have already discussed about in any factorial. So that could be a problem for some of the competitive exams. They ask you, for example, suppose they have given you 100 factorial and they ask you the question at the end of 100 factorials how many zeros are there. So that can be done very easily so that you know. So 26 factorial is nothing but this value, and this is quite big, so it's more than 4 into 2 to 10 to the power 26, so it's a huge number. So you cannot try all these options by your hand, so you need to do some programming which will help you to get the information. Now let us try to use some computers. So it's a quite decent computers which uses 1 million mean 10 lakhs means 10 lakh ciphers cipher alphabet per second. So it processes 10 lakh ciphers alphabet per second. So quite a good machine. And if you use this machine, it takes 10 to the power 13 years to exhaust all the options. And you'll be surprised to know that 10 to the power 13 years is more than the age of the universe. So our universe is not that old compared to this value. That means by using computers, quite a decent computers, you cannot exhaust all these possible values. So you cannot see this. So if your choice is like this, then you can understand that nobody can break this. And you will be surprised to know that when it was invented, people thought that nobody could break this because it's a too big number and no computer can search all possible options and you are pretty safe. But cryptography never goes in a straight line. So it's true that the search space, the key space is too big here for a computer even to exhaustively search all the options. But cryptography is not all about all exhaustive searches. So I will give you very simple way how to attack it. But before that, just have a look at this and whatever that I explained you, it's a kind of puzzle. Just within 5 minutes, can you give the answer of this? So this is a puzzle. Just a minute. Yeah. Can you give the answer of this puzzle? So it's a Sherlock Holmes and his assistant Watson. found a piece of paper containing a clue about a serial killer who is either Oliver or Peter. The clue read as Nigel. Okay, so it's a S means Sherlock Holmes. He says that, my dear Watson, I believe you have a guess about the cipher used here. So what John says, his assistant Watson says, my money is on substitution cipher. So they have
Sir,
guessed
if
that
it would have been
the
Peter,
name that was written.
sir, if it would have been Peter, then in
Okay,
the
let's
second
see.
and the fourth place in the Niger word should be the same alphabet, because there is E in Peter, both the
Yeah,
places. So it's not that, so it should be, and Peter
yeah,
must be innocent.
okay, yeah. So good. You understand? Rest of you understand the idea? So they understood that the scheme was written using substitution cipher. Just now I explained. Now it's Nigel. From Nigel, they have to guess whether it's Oliver or Peter. And they only know that the substitution cipher has been used. They have no clue about the key, what key was made and all. Now, Sherlock Holmes, they solved that problem. What was the problem? Now, anybody else can explain? Anybody else?
Yes, sir. For the substitution cipher, alphabet goes into a distinct alphabet. Every alphabet goes to some distinct alphabet. So here E cannot go to I and E both. So
Yes,
Peter must be innocent.
good. So distinct alphabet will go to distinct places. So here E is the repetition. So if this Nigel, no alphabets are repeated. So if it could be Peter, then within this Nigel, some alphabet should be occurred two times, but nothing is there, so it has to be Oliver. So see, you never know what is the value of the key, but still you can get information out of it. So that's idea, but I'm going to give you a very definite example of how this kind of schemes were attacked. Okay, that is known as frequency analysis. uh, okay, let me try to have a check. Like, how many of you in we have at present 18 students in my class. Now, if I ask you how many of your names start with S, T, and A. S, T. The first alphabet of your name comes with A, S, or T. I can see that here, many of you. So you can see that S, T, and S, T, and A. So A is there somewhere. Maybe A is my name. Two, three, four names are there. Uh, S is significant, and T's are also there. So out of 18, so there are 26 alphabets. I have taken only three alphabets, and I have seen that almost more than 50% of the students' name starts with only with these three alphabets. That means not all the alphabets in English language they occur with same frequency. It has been found by statisticians that E is the mostly used alphabet. T is the next mostly used alphabet, A is the next one, and so on. So not all the alphabets they occur equally frequent like others. So E is the mostly used alphabet. Not only that, there are some pair of alphabets. For example, TH is the mostly used paired alphabet together. Then HE, then IN, ER, and in a decreasing order. Not only that, there are triplet of alphabets occurring together, the most frequently used is THE, then ING, then AND, and so on. So English literature or every language does have a kind of peculiar properties that that language possesses. Based on that, the attacks happens. Now, if you look at in the substitution cipher, if one alphabet goes to D, then in the cipher text, wherever I will find D, I can understand that it actually comes from A. For example, suppose in this case, E goes to N. So in the cipher text, I will first count the frequency of each of the alphabets. If I found that N is the mostly used alphabet, then with high probability this N is nothing but the E. Okay, then I will check for the alphabets that happens twice, that happens thrice, and with after few runs you will find that many of the alphabets are basically you can distinguish them, and then once you know the formula then you can replace it, and after some time, after substituting this alphabets with the original one, you can visually recognize the original message. So whenever the engineering students or the students from usually ISER I usually take for summer. So whenever ISERs or IITs, when they come to me for the first time, the first thing that I usually give them to code is this. So you have a, so for that you need to have a sizable ciphertext. You cannot have a ciphertext of 2 lines. It should be a one-page ciphertext, so that you should have plenty of each alphabets. Okay, so that means you have plenty of alphabets. Now you can count. For example, say if you say that X is the mostly used alphabets in your ciphertext, then with high probability that that X was originally E in your plain text, and so on. Then after some times you will able to get information by just having visually. So the thing that was looking like impossible by computers, but by using this kind of technique, this is known as frequency analysis, one can break the substitution cipher very quickly and very easily, and that can be done within 45 minutes to 1 hour. So that's why I'm telling that cryptography is not like in a straight line. You never know from where you can have the attack and how you can attack this. So today I'll stop in here, and next class I will continue with more on few attacks, and then I will go for the public key crypto system where you will find that how really prime numbers plays the most important role.